All right, guys, today we're going to talk about writing two variable inequalities from word problems. There are certain strategies that we want to use when we're solving a word problem in general, but even with inequalities. Of course, we want to read the entire problem and highlight the key words that we need in order to solve the problem. Then we want to identify the variables, and then write the equation or inequality and solve if that's what's needed. Sometimes we'll just be told to write an inequality and not to solve, but pay attention to what's being asked. All right, so we have certain key words, at least, right? We say at the least we want this. That means it can be greater than or equal to. No more than means we don't want to go over, but we can be at that number or less than. So that's less than or equal to. More than means greater than. Less than means less than. And we'll probably be introduced to a few other terms. But for now, keep this in mind. The first problem says the Chiefs are down by 42 points at halftime. A field goal is 3 points and a touchdown with the pat is 7 points. Let X represent the number of field goals scored and Y the number of. Let X represent. It said highlight key terms, right? So let X represent the number of field goals scored and Y represent the number of touchdowns scored. Write the inequality that models the different number of points the Chiefs could score and not win. All right. Well, they can score and not win. Now, in order to win, they need 43 points, right? So score and not win means that we're talking less than or equal to, right? 42 points because they're down by 42. Now, certain rules of the game we got to know, like a field goal is 3 points and a touchdown is 7 points. That's pretty important. All right, so what do we come up with? Okay, 3 field goals. Field goals is represented by X. We were told right here, right? Plus 7 points per touchdown. So that's 7Y. It says write an inequality that models a different number of points the Chiefs could score and not win. So less than or equal to 42. And there we are, guys. We've solved our first one. We've written an equation for the first word problem. All right. In example 2, it says Elijah can spend at most, keyword, at most, $8.25 on snacks for a party. All right. Carrots cost $2 per package and grapes cost 75 cents per bag. Write an inequality to describe the situation. All right, so clearly for this party, we got grapes, carrots, and grapes. All right, he only has $8.25, and it says at most. At most means is the same as no more than, right? So at most is less than or equal to. So he can spend less than or equal to $8.25. Carrots cost $2 per package. So we're going to let, it doesn't tell us what to let X be. So we're going to let X be the carrots and Y be the grapes. So $2 per package of carrots plus 75 cents per package of grapes. At most he can spend, so less than or equal to $8.25. All right. A retailer sells 2 types of coffee beans. One type costs $9 per pound and the other type costs $7 per pound. Find all the possible amounts of the 2 different coffee beans that can be mixed together to get a quantity of beans costing $8.50 or less. Keyword, $8.50 or less. We know that one type is $7 per pound. The other type, that's $9 per pound. The other type is $7 per pound. All right, so per pound, one type, so $9 per pound for one type, and then $7 per pound for the other type, right? Always pay attention when you see each, every, per, right? That's giving us some information. So, find all the possible amounts of two different coffee beans, all right? And the quantity has to be 850 or less. Okay, so 9x plus 7y, right? Because x and y is the different types. And we can just write a note to ourselves. X equals the first type of coffee bean. And y is the second type of coffee bean. Right? And it's less than $8.50. All right, less than $8.50. Well, we've written it. It says find all possible amounts of the type. So now we got to kind of look at some combinations, right? And we can do that if need be. Now, it may be hard to note because you're like, well, if I put one here and one here, that's definitely going to be over 850. But remember, when we're talking about coffee beans and things like that, we do less than 1 pound. A lot of times we do, a quarter pound, a half a pound, things like that. So start thinking that way, and we'll go through this in class. All right. The rest of these, attempt to write an inequality, and then we'll come back and check tomorrow.